Good day and welcome to Dr. C2 and Mrs. C3's channel. Today we will solve a geometry problem given in the Australian Mathematics Competition in 2020. Imagine 5 unit squares, organized as shown in the figure, and a circumcircle to these squares. The question is to find out the radius of the circle. First, we see that the whole figure is symmetrical, considering an horizontal axis. It follows that the center of the circle is located on the axis, and more precisely, since it has to be within the circle, on the horizontal diameter of the circle. Second, we see that unfortunately we cannot apply the same reasoning vertically. However, if we introduce points A, B, C, D, E and F, as shown on the figure, we observe that 1. The distance between A and B is smaller than 1 unit, and 2. The distance between E and F is also smaller than 1 unit. Using these two observations, we can prove that the center O of the circle has to be located on the line segment CD. In our demonstration, because O is the center of the circle, the radii AO and OF have the same length. The center O cannot be on AB, as the distance between A and O would be smaller than 1, while the distance between O and F would be greater than 2. Similarly, the point O cannot be located between B and C, because the distance between A and O would be smaller than 2, while the distance between O and F would be greater than 2. We apply the same strategy on the right side of the circle. 1. The center O cannot be between E and F because the distance A and O would be greater than 3, while the distance between O and F would be smaller than 1. 2. The center O cannot be located between D and E as the distance AO would be greater than 2, while the distance OF would be smaller than 2. We conclude that O has to be located on the line segment CD. So, we prove that the center O of the circle has to be on the line segment CD. Let's say at a distance x from C. It gives us an idea to solve the problem. We could write the length of the red radius r in terms of x using Pythagoras' theorem. Then, we could write the length of the blue radius r also in terms of x. The red radius and the blue radius, having of course the same length, would give an equation with only one unknown, x. If we could solve this equation, we would obtain the numeric value of x. Finally, we would just have to replace x with its value in any of the two equations of r in terms of x. So, let's do that. First, we calculate the radius r joining the circle center to the left top vertex of the upper left squares in terms of x. As we have a right angle on the bottom left vertex of the triangle, we can use Pythagoras' theorem to get r squared equals 1 squared plus 1 plus x squared. After simplification, we obtain r equals the square root of x squared plus 2x plus 2. Second, we apply the same method to the radius from the circle center to the right top vertex of the right square. After simplification, we get r equals the square root of x squared minus 4x plus 17 over 4. The lengths of the two radii are the same, so we can write an equality between their values. We square both sides of the equation, remove the terms in x squared which cancel out, and, after simplification, obtain the value of x, 3/8. Our last task consists in replacing x with its value. For example, in the first equation of r, we obtain the value we are looking for, r equals the square root of 185 over 8. For very advanced users who love math formulas, we will now present another method to solve the problem. This method relies on the observation that the arrangement of squares can be considered as a quadrilateral inscribed in a circle. Indeed, 4 square vertices are on the circle. In this scenario, the formula of Parameshvara immediately gives the radius of the circumcircle of a quadrilateral. The formula itself has some analogies with Hero's formula, which gives the area of a triangle knowing the lengths of its 3 sides. But here, since we have a quadrilateral and not a triangle, the lengths of 4 sides are used. Also, like in Hero's formula, the semi-perimeter of the shape has to be calculated beforehand. Let's see how we could solve the problem using the formula. First, we calculate the top side A. As with the first method, we use Pythagoras' theorem to get a squared equals 3 squared plus 1/2 squared. That is, a equals the square root of 37 over 2. The side B is simply the side of the right unit square, so B equals 1. The arrangement of squares has an horizontal axis of symmetry, which immediately gives us the value of C. C equals A equals the square root of 37 over 2. Finally, the side D corresponds to the left sides of the 2 left squares. It follows that D equals 2. Now we can calculate the semi-perimeters. S equals 1/2 of the square root of 37 over 2 plus 1 plus the square root of 37 over 2 plus 2. After simplification, we find that S equals 1/2 of 3 plus the square root of 37. Replacing the pronumerals A, B, C, D, and S with their values in Parameshvara's formula, and with a bit of reorganization, we obtain the anticipated result. R equals the square root of 185 over 8. Of course, this result is the same as the result obtained with the first method. See you soon for more problem solving.